In this video, we'll demonstrate to you how the mobile app you developed for lab number 8 is expected to work. Lab number 8 has exactly the same format as lab number 7. So let's briefly review the workflow for your developments. Number 1, given the JUnit tests with the various test methods, you are supposed to build inside the model package all the various classes, either class or classes, depending on exactly what's indicated by the JUnit test. And then make sure you build a class, implement the methods by declaring as many attributes as you like, and also as many helper methods you like. You do not create any additional classes that are actually not indicated by the JUnit test. That's actually clearly specified in your lab number 8 instructions. Please know that. And then after you have built the model class or classes that pass all the JUnit test, you will be in a good position to move on to step number 2, which is to build the GUI layout. That's actually specified in your instruction. And then step number 3, you're going to define the controller class, the main activity.java class, by defining the controller methods which should be attached to the GUI buttons, and then to see how you can invoke the relevant model methods on the model objects. So that's pretty much similar to how you did it for lab number 7. So now for lab number 8 demo video, we just want to show to you some example usages that are actually suggested by your JUnit test case that you're given. However, we only give you some example usages. You are actually expected to write additional test cases and to test your app, especially on the JUnit test and also on the app itself. So that both are the test cases we're expecting you to do. But let's do the JUnit test first, and then we'll run alongside how they will correspond to the corresponding usage on the actual app. All right, let's now do it, and then you will see easily the correspondence between the two. We have shown this in lab number 7 already, so you'll be just the same. So hopefully that wouldn't be so surprising to you. All right, so let's now first of all launch the app over here, and then you can choose whatever model you like. For me, I simply chose Nexus 9. You can choose the same model if you wish. Okay, so now this is my tablets over here. So this will be the GUI layout for your lab number 8. So make sure you actually change the app name as required by your instruction, tic-tac-toe app, and also your first name, your last name, and also your student number. Okay, and then let's briefly go over the structure for the GUI. So you we call it tic-tac-toe game. You can review the game. That's actually specified in your instruction. So there are 2 players. It's like a 2-player game. So we got player X and player O. So player X will only put X's on the game board, and player O will only put O's on the game board. And then you can enter whatever string name you like onto the text field. We assume these fields are not really left empty always, just for simplicity. So you don't need to do any error checking on the names of the player. And then who plays first? So this will be a spinner for you to choose either player X and player O. And notice that player X will have the name that's actually specified in this particular input field, and player O refers to the player name that's specified in this text field over here, right? So when you actually output something about the status of the game, as we'll see, you have to say about either the name of the player X or the name of the player O. Just notice that. And then we assume that the very first button the user will click will be the start and restart game, because you must start a game in order to make some movement. And whenever you want to make a movement, which means the 2 players X and O will actually take turns. So either the player X will actually make the first move, and then the next move accordingly will be all the subsequent moves will be interleaving between the player X and player O, and etc. We're just simulating the real interaction between 2 players. All right, and then after you have started or restarted a particular new game, you can think about every time you click on the start and restart button, you should really reassign your model object to a new objects. All right, so that's a hint to you. And then you're going to enter once the player is actually ready to move, you must enter row number and column number. So it's a 3x3 game board that we are talking about. You will see that. And from the external user's point of view, we got the row number will be from 1 to 3. And also the column number will be from 1 to 3. However, internally in your two-dimensional array, you have to convert it into 0, 1, and 2 for indices. That's also another hint for you. All right, and then whenever you say move, either the move will actually generate some actual movement because the row column number are simply valid. I'll show you some cases where they are valid and some cases where they are invalid. In case where the row and number, either one of them is invalid, you will have to update the status of the game by using some error message, pretty much like a game, pretty much like how you did it for the bank. Okay, and then in the very beginning, when you launch the app, this will be some fixed constant string which you must output to the mobile screen. No game has been started. Okay, that's something you have to maybe possibly to put this on the onCreates controller method. That's another hint for you. Big hints. Okay. All right, so let's now see how we can play the game. And then, of course, there will be some text view over here that will display the status of the game. And you should really refer to the PDF instruction for Lab 8 about how to define the status of the game. So we got a precise definition over there. You should really look at that before you start your developments as well. All right, let's now play the game. Okay, let's now go for test 1A. There might be some slight differences. I'm not too sure because after recording this video, I might extend or revise the test cases slightly. So, but don't worry. But it just focus more on the example usages for the app I'm doing. Okay. All right. Let's now let me just start from test 1A. So we are creating a new game, and then we want to we always put player X name and then player O name. Let's say we got Suyang and Yuna. Okay. Let's say for player X, we'll say Suyang. And also for player O, we'll have Yuna. Okay, and by default, you can see that player X is simply selected. So that's something will also be reflected in the test case in the JUnits test I'll show to you. All right, and then who plays first? You can see by default it will simply just be Suyang. It's because player X by default is simply just chosen. And then you can see Suyang is the name for the player X. So now, as soon as I say start, you can think about start and restart is corresponding to actually creating by creating a new game objects like this line over here. Okay, you can think of that way. All right. If I now say start, restart, you can see now we actually got different parts you have to display over here. But however, they will be the return value possibly from different methods in the model. Let's talk about it quickly. This part over here is the output, the pretty printing of the board of the game. You can see it's a 3x3, 1, 2, 3, 3 rows, and also 1, 2, 3, 3 columns. So this will be the output from get board over here, right? But that one there is simply at the model level is simply returning a two-dimensional array, and every slot, every element in the array is simply a character, is a primitive type array. Okay. You can make it a string, but for this assignment, for this lab, we make it a character just to save some space. And the second part of the status for the display will be just about some status over here. So the status can be different possibilities, but for now, possibility number 1, it would be simply so since there was no error when we created the game, so you will simply say who is going to be the next to play. So we say Suyang's turn to play. It's simply because we chose player X, who is Suyang, and she actually should play first. So now in this case, the status will show Suyang's turn to play, right? And then let's see this. I think that's all I want to show in this particular test case over here. So let me recap very quickly for you. So there will be several public methods you will have to implement. Number 1, get current player over here. So whose turn is it to play right now? For that, it will be player X, who is Suyang. And also let's see, that'll be the get current player, and also get status. You can think about get status return value is really being used over here at the bottom over here, the second part. And then another third method will be get board. So this will be returning some two-dimensional array of characters. In that case, in your controller method, you may just have to somehow turn this particular character array into a single string by accumulating the string. That's something to be done on the controller side. But at the model level, you simply just return a two-dimensional array. Okay, hopefully that's also good hints for you. All right, that's about 1A. Okay, and let's see 1B over here. So for 1B, we simply just want to create another game, right? You can think about whenever I see new game over here. So that simply means I still got Suyang and Yuna, the same two players, right? I'm going to use the same names throughout the demo. So that means new game will correspond to another button click over here. So let me click it again. All right, it's actually going to be the same so far. And then, but this time I'm going to set, this will be another method you want to implement. I want to say this time I want this particular game to start with an player O. You can see the argument over here is taking either X or O, right? You can also read the inline comments for the JUnit test. I'm not going to repeat it. You can read it, right? It also states some assumptions you can actually take into consideration. Okay, set who play first. So that will be O. So that means I'm going to actually put, you can think about in some way, thinking this way. G.set who plays first is really about after you have created this particular objects, you're also going to set some internal maybe attributes to say player O is going to is actually going to play first. That's something up to your implementation, right? However, the way for me to simulate it on the app usage is pretty much as if I actually chose player O over here and then say start. Okay, it's slightly different, between the mobile screen and also the JUnit test. But I just explained to you. You can think of in your controller method after you have created this particular new game objects over here, you're actually going to retrieve the input from the spinner, and then depending on what has been chosen, you're going to set who plays first accordingly, right? That's just another hint for you. All right, let's say here we set the who plays first to be player O, who is Yuna. All right, so let's say she will be it will be her turn to actually play, right? You can see now the message here is a bit different. Okay, so that'll be Yuna's turn to play. So that's a status. Think about if there's no error from the movement or from the initialization, so that means you just want to, the status will just be whose turn to play. Okay, we'll see other status message as well a little bit later. And then the board, when you say get board, initially will just be the board as well. And another thing to mention, initially none of the slots is actually occupied by either X or O. By the way, X and O, they're both in lower cases, not capitals. Otherwise, you will fail the JUnit test. And when they are unoccupied, you will simply use underscore over here. It's not dash, right? It's underscore. Okay. All right, and then let's see anything else. And then we can simply also choose maybe back to player X and then say restart a new game. And then you can see back to the game where Suyang should be the first player, right? Player X, right? You pretty much get the idea. So in the beginning, you just want to show you how things can be manipulated even before you try to make the first movement. All right, let's now start from test number 2 over here. Okay, for test number 2, we are going to create a new game with Suyang and Yuna. Okay, let's do it again. And then we simply just want to leave it as default. We don't want just player X to really to play first. Let me do it once more. Okay, like a restart. And then let's now try to make some movement. So here I'm doing -2 and 4. Apparently, you can see here -2 and also 4. What will be the validity constraints for the row and column number? They should be between 1 and 3, right? 1 and 3. So this -2 will be too small and 4 will be too large, right? So both of them are actually invalid. But we are only going to display one error message. So this is similar to your lab number 7. When there are multiple errors occurring simultaneously, you're only going to display the error with the highest priority. But how do you know the priority? You have to check the error table in your Lab8 instruction. I'll leave you check it. But now in this case, the row number actually got higher priority. So if I say move over here, it's going to say the current status. You can see now it's not going to say whose turn to play, but rather it's going to say -2, which has the higher priority over here. Row -2 is invalid, right? Okay. And then let's now try another input over here. Let's say we change from -2 to 2 over here. So now the row number is actually valid, but the column number is too large. It's invalid. So if we say move again, it's going to say column 4 is invalid, right? Okay, hopefully that makes sense to you. All right, and then we're just going to do another one over here. So after, oh, okay, I see. So now we're done with the test number 2 as well, right? Test number 2 is simply just showed to you with a -2, 4, and also 2, 4, right? So you just got error without any movement. Whenever there's any error, so that means the current player the player whose turn to play does not change, right? So that means they can keep trying until they actually enter the valid numbers for both the row and column. All right, let's now move on to test number 3 over here. So now for test number 3, we still got Suyang and Yuna, okay, and then we still got player X over here. But for now, why don't we simply just clear everything? Let me stop the app and then launch a new instance just from scratch, okay? Number 3, number 4 will be a little bit long, so let me just start from scratch. I think that'll be better. All right, let's say here we want to create a game. Player X will still be Suyang, and player O will be Yuna over here. All right, and then we simply want to leave it as default. Let's say player X will actually be the first one to play. Okay, so now when I say start a game, initially it's going to be Suyang's turn to play, right? And also we got this board over here. Everything is the same as before. Let's now make some movement. Okay, so now you can see now we know that it's going to be Suyang's turn to play, and Suyang is the X player. Let's now say we want to do 2 and 2. So which means Suyang, the X player, is going to put the X at 2, 2. So 2, 2 over here simply means row number 2, 1 and 2. Row number 2 here, and column number 2, 1 and 2. So we're going to put X over here. Right? You can see that in the JUnit test, we simply got X over here. You can get used to about how we can refer to the row and column number from the external user's point of view. But you have to convert it inside your program about valid indices into your 2-dimensional array. I'll leave that detail to you. Right? If I say move over here, you can see now X has been placed over here. Another hint for you. So the exact pretty printing of the board is kind of up to you in the controller method. You may just want to leave some space actually between the underscore or between the characters. And then make sure you use the lower X and lower O. So that'll be pretty print better. That's another hint for you. All right, so now after this, okay, so now you can see it will be Yuna's turn to play, right? Yuna is the next player, right? You can see just go on. Suyang, Yuna, Suyang, Yuna, Suyang, Yuna, until either we have a winner or we have a tie. That's basically what tic-tac-toe is about for the two players to proceed. All right, so now after 2-2, and let's now go for 1-3, right? So now it will be Yuna's turn. So Yuna is going, she's the O player, so you'll be 1 and also 3, right? And you can kind of predict where we're going to put the O, right? So 1 and also 3, it should be this one here, right? This right corner, right? You can see O here. And then you can see now it will be Suyang's turn to play. Hopefully you follow the logic, right? So now I can speed up a little bit. So now after 1-3, and then let's say it's now Suyang's turn. However, Suyang would choose to move to 1-3 to actually simply move to 1-3 for the next draw. Let's say if Suyang's turn to play, let's say she simply just say 1-3. However, if you say move over here, what's going to happen? Apparently 1-3 is already occupied, so you just cannot move there. So if you say move, the status is going to say error, slot 1-3 is already occupied. You can see in this case, both the row and column number individually are valid, but the slot they refer to is already occupied by some previous or the same player. So that means you cannot draw that. Okay, that makes sense, of course. All right, so now after this, if you can see, that's exactly the error you will see in the JUnit test. Let's now move on to maybe 3-3. So now the same, you can see it is still Suyang's turn, right? So Suyang is due to really take her turn, so she can keep trying until she can make a successful move. That's really what the game is about. All right, let's now try 3-3. So now we're going to draw X over here. If I say move, so you can see X drawn over here. So now it'll be Yuna's turn. And then for Yuna's turn, we're going to do 1-2. Okay, so now let's try 1 and also 2. Let's close the keyboard and I say move. Okay, so you can see Yuna is here, right? 1-2. And then after that, let's say Suyang is going to do 1-1. Okay, move 1-1. So now after 1-1, you can see that 1-1 will be here for X. According to tic-tac-toe, a player will win if after their latest move, if they can make a diagonal either this way or maybe this way, or if they can make a horizontal line like this, or they can make a vertical line. So you can see the definition in the PDF for the instruction. So they will win. So now as soon as we say move over here, it's going to say game is over. You can see the status over here. So the status basically can tell you either is somebody else turn to move, or it can be an error message, or it can be when the game is over. Either because there's a winner or there's a tie. We'll see a tie in just a moment. So you can see after this, it's going to say game is over with Suyang, the name of the X player, being the winner, right? You can see you got to keep track of who the winner is. So it's really important. Again, we're only showing you one example usage. You should really try to play with the game and try to make try to do some exhaustive tests yourself. I think that's also part of the software development process you want to get committed to. All right, so now after 1-1, you can see game is over with Suyang being the winner. Okay, that's the status. And let's say now, let's try something interesting. And oh, by the way, you can see after, very important to see, after we have done, after the game is over, you can see the current player would not switch from Suyang to Yuna, not anymore. So the current player would just be now, right? So that's something important for you to program for your model method, right? As soon as the game is over, there will be nobody's turn to actually continue because the game is over. So the only way to really start a new game is by clicking on this particular button, but we wouldn't do that just yet. Okay, so now the game current play should be null, and game's over, and then so that will be the state for the winning state, right? The diagonal. All right, and now let's try this. If I simply tried it, let's say even though there's no current player, but I still try, what's gonna happen if I say 4 and -2? Since there's no current player and then the game's over, if I try 4 -2, apparently 4 is too large for row number, -2 is too small for the column number. So we got 2 errors. Plus, the game is already over. That's a 3rd error. But which one got a higher priority? Got the highest priority in this case. It turns out the game being over and you're still trying to make a move. That will be the error with the highest priority. You can check the error table in your instruction. So now if I say move, it's going to say error. Game is already over with a winner. Right? It's a very informative justification why you just cannot make a move. Right? Even though. So you can see in this case, even though the row and column are invalid, but this error over here about the game being over with a winner, that one has a higher priority, right? Okay, let's try another one. What if I try, let's say 1 and -2? So now in this case, 1 and -2, apparently the column number is invalid, but doesn't matter. If you say move, it's going to say game is already over with the winner, right? You can see the same error message. Try another one. What if I say 1 and 2? Right, you can see both the row and column are valid in isolation, but 1 and 2 is actually referring to the occupied slot over here by Yuna, the circle, the O. However, if you say move, it's not going to say the error about being occupied. It's still because this error here has a higher priority, right? Hopefully that makes sense to you. All right, that's about number 3. Okay, so the only scenario we have not seen is about the time. Why don't we do that quickly, right? So, but you pretty much get the idea for the game. Let me now simply stop the app and let me launch it again. Okay, and then let's do the final test over here about producing a tie, and then everything else will be up to you to really implement the model, test the app, and then write as many test cases as you can. So that'll be the best way to really exercise your software development ability. All right, so let's say again we're gonna get player X will be Suyang and also Yuna, and then you can see set who plays first will be O. Let's choose O over here, and then close the keyboard. And then if I say start a new game, you can see it will be Yuna's turn to play. Right, it will be player O. Remember, player X is Suyang, player O is Yuna. All right, so now it'll be Yuna's turn to play, right? Let's now play it one by one. So now it'll be Yuna's turn to play. Let's now do 2 and 3, right? You can just keep seeing the line over here, right? I'm not going to point there to you. So 2 and 3. And then if I say move, right? It's here. Okay, Yuna puts O over there. And, okay, and then now we switch the turn to the X player, Suyang. And for Suyang, it's going to be 3-1. Okay, let me be careful. Okay. It's been carefully designed, so I should really enter everything correctly. 3-1. Okay, so now you can see Suyang, X player, is over here. All right, and the next turn will be Yuna. You can see the Yuna's turn. So it's going to be 2-1. And then I'm going to say move. Right, you can see here. Right, nobody has 1 just yet. And then the next one will be Suyang. It will be 2-2. 2-2. Close the keyboard and then move. right? Over here, Suyang seems to be winning if she can get it, but will Yuna actually allow her to move, to win? That's the thing, right? So after 2-2, let's say 1-3. Yeah, very smart Yuna. She's gonna say 1-3 over here. Is going to block the winning chance for her sister Suyang, and then move. All right, you can see now Suyang cannot really make the diagonal, right? You can see the idea, right? We are simulating exactly how people play in the real life, in reality. All right, so now it'll be Suyang's turn to play, let's say 3-3. And also, Suyang wouldn't let Yuna win, because if Yuna just is only have this slot left, but Suyang is smart enough to say, no, I'm not gonna let you win. All right, and then Suyang's gonna say 3-3 and move. So she also blocked Yuna's chance to win. All right, and then it'll be Yuna's turn to play. And let's say, okay, and Suyang, she could have won if Yuna didn't choose to put on the top left corner, because Suyang can make a diagonal. But Yuna is smart enough to say 1-1. All right, that's for Yuna. So it'll be 1-1 and then move. Right, you can see here, right? Nobody has won. And then it'll be Suyang's turn. We only got 2 slots left. And then 1-2. 1-2 over here. And Suyang is going to say 1-2 over here. You can see up to now, even though not the case that all the slots are occupied, you can see still one slot is unoccupied, the game could have simply determined that it's going to be a tie. However, for simplicity for your app, you can always wait until all the 9 slots. If all the 9 slots have been occupied, but there was not yet a winner, you can say it's a tie. You don't really have to determine at the earliest possible timing. You don't have to, right? Just remember, you can always wait until all the 9 slots have been occupied. All right, so now let's do one more, and then the final one is going to be Yuna's turn. It's going to be 3-2. And 3-2 over here. Let's close the keyboard. So Yuna is gonna play put O over here, right? I'm gonna say move, right? So you can see after this, the current game status will change. You can see that'll be the final layout for the board. Game is over with a tie between Suyang and Yuna, and the requirement will be you should really put a name first for the X player first, and then the O player second. All right, always the case, because there's no really winning or losing. All right, so after that, let's do a little bit more error checking over here. So now you can see the game's over. Similar idea. Let's still try maybe 4 and -2. So both of the row and column numbers are invalid. However, the game being over with a tie has higher priority. You can check the error table again, right? So now if I say move, it's going to say error, game is already over with a tie, right? Rather than with a winner. Okay, let's try another one. Let's say 1 and -2. So you can see this time the row is actually valid, but the column is not valid. However, the game being over has the higher priority. So now you can say move. Okay, the same. Game is already over with a tie, right? Even if you say move. Finally, if I say 1 and 2 over here, you can see 1-2. 1-2 is actually occupied by Suyang's drawing over here. However, if you say move, it's going to be the same, because game being over with a tie has higher priority. Again, you should really check the error table. All right, that's about all the JUnit tests you're given. However, as I said, it's really important for you to really try out other scenarios, maybe other ways to really reach out a tie, and also other ways where player X can really win with a different diagonal direction or with a different line, and also for player O to win, right? Sometimes it could be the player who started first to win. Well, sometimes it could be the player who started second to win, right? You really want to try different scenario for your testing purpose. All right, so I think that'll be enough, comprehensive enough for you to actually get started building your app. All right, enjoy. So this will be your final app for this course. Have fun. Take care.